Hello dear students, welcome to YourPedia. Today in this session we are going to discuss the previously asked control system questions in TSPSC examination. Okay, in 2015 TSPSC conducted one examination for electrical engineers. So in that control system all questions I am going to discuss. Before I enter into the question, let's discuss about syllabus and for how many marks control system was asked in 2015, 2017 and 2020 or we are going to see. Okay, let's enter into the syllabus first. Let's discuss the syllabus first. Yeah, this is the syllabus. Principles of feedback, transfer function, block diagrams, steady state errors, Routh and Nyquist techniques, Bode plots, root loci, lag lead and lead lag compensation techniques, state space model, state transition matrix, controllability and observability. This is same as that of GATE syllabus. Okay, syllabus is same as that of GATE syllabus. Yes. Now let's see for how many marks in which year control system was asked and how many questions we got. Observe, just I am concentrating only on control systems. Okay, control systems in this HMWS is one of the examination that was conducted by TSPSC, Telangana Public Service Commission. Okay, now AEE also will be conducted by TSPSC. Almost the questions of TSPSC looks in the same manner. Okay, so observe 15 questions we got. Each question carries 2 marks, then 30 marks. In 2015, AEE electrical 15 questions were asked from control systems, again 30 marks. HMWS 2020 again 14 questions were asked. Yes, for 2 marks each question is 28 marks. So more or less I can say for 30 marks control system will be asked in TSPSC AEE. Scoring that 30 marks is going to be very easy. Now in this session I am going to cover all previous AEE questions, not AEE questions, HMWS 2015 all control system questions I am going to cover. In the upcoming session I will be covering all AEE questions. Next section I am going to cover all HMWS 2820 questions. But either it is HMWS or AEE, both are conducted by TSPSC. The question models will be same. Fine. Yeah. Come here. Let's look at the first question. Okay. The open loop transfer function of a control system is g of s into h of s is equal to 10 into s plus 1 by s into s minus 1. Which of the following is the gain margin of the system? Simple question mark, just right question. There is no logic in that. Okay, just a procedure. There is no logic. Let me solve. Very simple, we are going to solve. So we all know that gain margin is equal to, so in DBC asked, the formula is 20 log mod of 1 by g of j omega h of j omega at omega equal to omega pc. Yes, the reciprocal of the open loop transfer function by replacing s with j omega, and that omega should be replaced with phase crossover frequency, where omega pc is phase crossover frequency, and apply 20 log to that, then you are going to get in decibels. So to do this one, first of all we need this phase crossover frequency. Let's find that phase crossover frequency first. Okay, yeah, how to find phase crossover frequency, let me tell you. Okay, at omega equal to omega pc, from the definition itself, it is a frequency at which angle of the transfer function is equal to minus 180. At omega equal to omega pc, angle of g of j omega h of j omega is equal to minus 180 degrees. Now how to get the angle of that? Then what is the transfer function? 10 into, come back, yes, what it is, transfer function is 10 into s plus 1 by s into s minus 1. 10 into, yes, s plus 1 by s into s minus 1. We have to replace this s with j omega. Why? Because we are in which analysis? Frequency response analysis. Remember one point, in entire frequency response analysis, s should be replaced with j omega. Frequency response analysis is same as that of AC analysis, what we are doing in network analysis. Okay, yeah. Now we have to replace s with j omega pc and make that equal to minus 180. We all know one thing, that one pole at origin will give an angle of minus 90. Yes, see 90 downside, when it comes to upside minus 90, that way also you can think. And this is in second quadrant, I can say second quadrant, that can be minus of 180 minus tan inverse of omega pc by 1, tan inverse of omega pc by 1 close the bracket, and numerator plus tan inverse of omega pc by 1 is equals to minus 180. Okay, I can say this minus 20, this minus 20 gone, minus 90, minus of minus will be plus plus tan inverse of omega pc plus tan inverse of omega pc, minus 90 plus 2 tan inverse of omega pc we have. Let's take a new page and solve further for the answer. Yes, so we get minus 90 plus 2 times of tan inverse of omega pc is equal to 0 degrees, in fact 0. Now 2 times of tan inverse of omega pc is equal to 90 degrees. Now if we solve further, tan inverse of omega pc is equal to 45 degrees. Now from this one directly we can write phase crossover frequency omega pc equal to 1 radians per second. 1 radian per second. Omega pc is equal to 1 radian per second. Now what I have to do, substitute this one in the first formula what we taken, that is gain margin is equals to 20 log of 1 by mod of g of j omega h of j omega at omega equal to omega pc. Now let me take a new page and let me solve. Yes, observe what is that g of j omega h of j omega. You have to replace s with j omega, 10 into j omega plus 1 by j omega into j omega minus 1. Magnitude of that g of j omega h of j omega magnitude is equal to 10 by omega. That's all, because this magnitude will be root of omega square plus 1, this magnitude is also root of omega square plus 1, both will get cancelled. Now we want, see, I'll write like this, gain margin in decibels is equal to 20 log of reciprocal of this one, omega by 10, where at omega equal to omega pc, that is equal to 1 we got it as 1. In fact 1 radians per second. Always you must write the units, otherwise you'll commit mistake in the examination. Yes, now how much is omega pc? That is 1 by 10 will be 0.1. Now I am doing that here, final answer. Yes, let me take a different color for the final answer. So gain margin is equal to 20 log of 1 mod of 1 by 10, that is equal to 20 log of 0.1, that is equal to 20 log of 10 to the power of minus 1, that is equal to minus 20 dB. The gain margin is minus 20 dB. So for your explanation purpose I took these many steps, otherwise within 30 seconds we will complete this one in the examination. So you can skip many number of steps in this one. Okay, you need not to do this clearly in the examination to save your time. You can do with the short type of calculations. Okay, please follow that, then only your time will be saved, otherwise you will run out of time in the examination. Yeah. Now let's see which option is correct for the given question. Minus 20 dB. Option 2 is correct. Option 2 is correct. Yes. Let's go to the next question. Yeah. This is also a very simple question. So without pen paper, I will tell you how to answer this one. Okay. Many people will go for RH criteria, but no need of that. Okay. So how to get shortcuts and all those we'll be discussing in classes, in the upcoming classes. But here I'll tell you what is a shortcut. See, I'll tell you the general procedure as well as shortcut. General procedure I'm not going to do. Anyhow, you know that. But shortcut I'll be doing. Come on. What is that? Characteristic equation of a control system is s power 4 plus 2s cube plus 6x square plus 8s plus 8 equal to 0. Which of the following is a symmetric root pair of the system? First of all, let's know the stability of the system. Let me write the characteristic equation, okay, for my reference purpose here. Yeah, characteristic equation is equal to s power 4 plus 2s cube plus 6s square plus 8s plus 8 equal to 0. Does it satisfy all necessary conditions? Yes, it satisfied all necessary conditions. What are the necessary conditions? None of the coefficients should miss in the given characteristic equation, and there must not be any sign change between the coefficients of the given characteristic equation. If you take this given characteristic equation, there is no sign change between the coefficients of the given characteristic equation. Okay, all necessary conditions got satisfied. Then what is a sufficient condition? You have to go for RH criteria. There should not be any sign change in the first column of row array for the system to be stable. That is the sufficient condition. But in a very short way, I'll check for two conditions. Let me write what are those two conditions. BC is greater than AD. First one. Second one is D equal to B square E by BC minus AD. So what is this? This is the condition for a fourth order system. For a fourth order system to be marginally stable. To be marginally stable. Yes, this is the condition. Sir, what are A, B, C, D's? You can write this one as as power 4, this characteristic equation generally, bs cube plus cs square plus ds plus e equals to 0. This way you can write. This way you can write. Okay. Now ABCDs are coefficients of these S parts. ABCDs are coefficients of that S parts. You can compare. Now, why I am checking this one? So immediately you'll get a question in your mind. Sir, why you directly checking about the marginal stability? If you look at the options, all options are having plus or minus j. Okay. For a system, if there are imaginary roots, then the system is said to be marginally stable. If there are no right side roots and repeated, marginally stable. Okay. Sorry. If there are no repeated roots on imaginary axis. Very clear? Yes. I'll repeat it for your clarity. If you look at the options, all options are having imaginary roots. If a system is having imaginary roots without repeated imaginary roots and without any right side roots, then the system is said to be marginally stable. So that's why I'm checking for marginal stability. If it is marginal stability, yes, then my answer is going to be very easy. Yeah. Check here. Yeah, let's take one more page. In that page again we will write the characteristic equation, then we are going to check. Yeah, what is the characteristic equation? The characteristic equation is, yes, s power 4, I didn't remember, I have to go back. Yes, s power 4 2688. Yes, 2688 equals to 0. Now check for the condition. BC is greater than AD or not? BC is greater than AD or not? BC, yes sir, 12 is greater than AD. Yes, it is 8. Yes, sorry, I wrote again 12, it is 8. Yes, first condition is satisfied. Second condition is D is equal to, what is there in the place of D? D is equal to B square is 4, E is 8 by BC minus AD. So 12 minus 8 is 4, 4 gone, 8 is equal to 8. This is also satisfied. Therefore, I can say that my system is marginally stable. The given system is marginally stable. If a system is marginally stable, yes, it's going to have roots on imaginary axis without repetition. The location of the roots is omega oscillations. Yes, omega oscillations is equal to under root of yes, d by b for fourth order. For third order, it is under root of d by b, that is equal to under root of c by a. But here in fourth order, it is under root of d by b. What is d? What is d? D is 8 by, what is b? B is 2. How much it is? Omega oscillations is equal to 2 radians per second. 2 radians per second. Yes. Now, sir, why do we find omega oscillations? Omega oscillations will give a lot of clarity. I will tell you what is that omega oscillations. Yes. Now, location of poles on imaginary axis. On imaginary axis, S is equal to plus or minus j omega oscillations. Okay. What is the omega oscillations we got? Plus or minus j2. The answer is S is equal to plus or minus j2. See, the oscillation frequency of a marginally stable system will give us the location of poles on imaginary axis. Which option is correct? Which option is correct? Let me go for that. Let us choose the option. Plus or minus j2, option 3 is absolutely correct. Option 3. Let's go to the next question. Yeah. A question from state variable analysis. See, definitely one question at least will be asked from state variable analysis, whatever maybe the exam it is. Either it is a state level exam or central exam or GATE or ESC. See, in ESC examination, number of questions will be asked from state variable analysis. In GATE examination, definitely every year one question from state variable analysis. If you take any state level PSUs or state level other generation corporations or DISCOMs or public service commissions like TSPSC, definitely one question should be there from state variable analysis. That much importance it is having. State variable analysis is also called as modern control systems, okay, or it is also called as state space analysis. Read the question carefully. The system, yes, x dot of t is equal to a into x of t plus b into u of t with a equal to -1 2 0 2, b equal to 0 1 is stable and controllable, stable but uncontrollable, unstable but controllable, unstable and uncontrollable. He is asking to check whether the given system is stable or not, or controllable or uncontrollable. First let's see the stability. What is the characteristic equation? Characteristic equation is equal to mod of Si minus A is equal to 0, where A is a matrix, I is also a matrix, identity matrix. Okay, so characteristic equation is equal to 0. See, I can write like this. Instead of that, I can write like this: S into matrix is 1 0 0 1 minus A. What does the matrix say? Matrix A is -1 2 0 2 it is. Yes, that is equal to 0. So if we solve it further, yes, we are going to get S0 0 S, yes, minus of -1 2 0 2, -1 2 0 2. Yes, now let me take a new page. And copy this one yes. Yeah, so characteristic equation is equal to, yeah, let's come back. What I'm going to get, S minus of minus will be S plus 1. Yeah, the first one is S plus 1. Second one is 0 minus 2. 0 minus 2 will be minus 2. 0 minus 2 will be minus 2. Yes. The third one is 0 minus 0 will be 0. Yeah, 0 minus 0 will be 0. The fourth one is, the fourth one is S minus 2. S minus 2. S minus 2 will be S minus 2. Observe. Now is equal to 0. Now how to get the characteristic equation? Yes, that it is S plus 1 into S minus 2 minus of 0 into minus 2 equals to 0. So characteristic equation is equal to S plus 1 into S minus 2. If you observe, there is one root in the right half of S plane. This is sigma, this is j omega. At a 2 there is a root, at a plus 2 in fact, at a minus 1 there is a pole. This pole is making our system unstable. The given system is unstable. Okay, very clearly it is. The given system is what, unstable. Let's check for controllability also. How to check the controllability? Yes, the controllability matrix QC is equal to B, AB, A square B and so on. But here we have only 2 by 2 matrix B and AB. So what is matrix B? What is matrix B and AB? Yeah, what is the matrix B given by the examiner? 0 1 it is, and A is -1 2 0 2. Yeah, this is 0 1. Yeah, this is 0 1. A is, yes, A is -1 2 0 2. Yeah, let me check it once again. Yeah, how much it is? A is -1 2 0 2, -1 2 0 2, -1 2 0 2 into 0 1. BAB, right? BAB. Now QC is equal to, yes, 0 1, and if you do this, how much are going to get? -1 into 0 0. This is 2, this is 0, this is 2. Yes, this that is not equal to 0. 2 by 2 matrix that is not equal to 0. Then what is the rank of the matrix? 2. If the rank of the matrix is less than the matrix size, anyhow square matrix we are going to take, a 2 by 2 matrix or n by n matrix. If the rank of the matrix is less than n, we can say that it is uncontrollable, but it is equal to, yes, QC rank is equal to 2. Therefore we can say that system is controllable. Suppose if its det is equal to 0, then we can say that its rank is not equal to 2, it is less than 2, then we can say that it is uncontrollable. This particular test is called as Kalman's test. Yeah, the test for controllability what we conducted now is called as, yes, Kalman's test. It is what? Kalman's test. Fine. Let's go to the next question. Yeah, you can find the answer in the options. Answer in the options. It is unstable but controllable. Unstable but controllable. Option 3 it is. Option 3. Let's go to the next question. Next question. Come. Yeah. A unity feedback system has an open loop transfer function g of s equal to s plus 2 by s plus 1 into s minus 1. The number of encirclements of the point -1 comma j0 in the Nyquist closed loop system is. Many people will go with that Nyquist diagram and all. I'll simplify this question very easily. We all know that number of encirclements of the critical point -1 comma j0 is equal to n, that is equal to p minus z, where p is equal to number of open loop poles in RHP. Number of open loop poles in RHP. How much it is from the given question? It is 1. But because we have one pole in the right half of S-plane. We have one pole in the right half of S-plane. Then what is Z? What is Z? Z is the number of closed loop poles which are in RHP. Yes. Number of, yes, closed loop poles in right half of S-plane. Number of closed loop poles in the right half of S-plane. How to find that? Get the characteristic equation. Get the characteristic equation. What we are going to get? Yes, s square minus 1 plus s plus 2 is equal to 0. Yes, s square plus s plus 2 is equal to 0. I can say z is equal to 0. Why? Because a second order system, if necessary conditions are satisfied, by default the sufficient condition also will satisfy. There is no separate criteria for a second order system to be stable if it satisfies necessary conditions. Satisfaction of necessary conditions is sufficient for first and second order systems. The condition on stability will start from third order if necessary conditions are satisfied. Okay, for first and second order system, just by looking at the characteristic equation we can tell that it is stable. No testing required. Just by looking at the coefficients of the characteristic equation we can tell. So z is equal to 0. Then n is equal to what, ma? N is equal to p minus z. So n is equal to p is 1, z is 0, that is equal to 1. So number of encirclements of a critical point -1 comma j0 is equal to 1. 1 means plus 1. Plus 1 means the encirclements are counterclock or anti-clock. Sorry. Counterclock or anti-clock. If it is -1, the number of encirclements of the critical point -1 comma j0 are clockwise in direction. Look at the option. Which option is correct? One counterclock encirclement comma stable. Yes, it is stable. Yes, the given system is stable. Yes, yeah, one counterclock encirclement. Option 1. Look at the option 2 also. One clockwise. No, that is +1. Two counterclocks. No, no encirclements. No, we have one encirclement. N is equal to 1 we got. Let's go to the next question. See, that much simple it is if you use your 100% of your brain while solving the questions. Okay, so don't go for a lengthy path. See, anyone can solve a given question if more time is given, but in the examination we have some stipulated amount of time, not too much of time. Therefore, you use all your techniques to do it very shortly. Okay, yeah. Anyhow, in the class we are going to learn all possible shortcuts. Yeah, look at this. The open loop transfer function of a unity feedback system is given by g of s is equal to k by s into 1 plus st. By what factor the gain k should be multiplied so that the damping ratio is increased from 0.3 to 0.6. He is saying that initially damping ratio is 0.3. He want to increase that to 0.6. By what factor he want to multiply that k? Okay, yeah, let me do that. What is the transfer function given? G of s is equal to k by s into 1 plus st. Now what is the characteristic equation? S square t plus s plus k equal to 0. Now what is the damping ratio? Damping ratio. I'll apply a shortcut for damping ratio formula also. That is zeta is equal to b by 2 root c. Remember that zeta is equal to b by 2 root c if the characteristic equation is in the form of if the characteristic equation is in the form of characteristic equation is equal to s square plus bs plus c is equal to 0. Okay, see, this s square must be free from any other coefficients apart from 1. Okay, it may have 1 but not any other coefficient, so that's why I taken t common and I made it in this way. Now what I'm going to get, zeta is equal to, in place of b what I have, 1 by t, b by, yes, 2 times of under root c. In place of t, in place of c what we have, under root of k by t. So from this one, if you see, t value not mentioned, even in fact k values are also not mentioned, and t value is not going to change, but he is asking the change in the k value so that zeta value will be increased from 0.3 to 0.6. So I can tell you one thing, that zeta is inversely proportional to t, inversely proportional to under root k. Yes, sorry, I'll write it again. Zeta is inversely proportional to k, root k in fact. Now from this one, zeta 1 by zeta 2 is equal to under root of k2 by k1. So zeta 1 by zeta 2 whole square is equal to k2 by k1. So k2 is equal to k1 into, yes, zeta 1 by zeta 2 whole square. Yes, k2 is equal to k1. Yes, remain it as k1 only. Why? Because he want by how much factor this k1 should be multiplied So that he is going to get a 0.6 as zeta, as a new zeta. What is the old zeta? 0.3, new one is 0.6. Yes, whole square. So K2 is equal to K1 into, yes, how much it is? 0.9 by 0.36. Yes, 0.9 by 0.36. Now you solve it, you are going to get K2 is equal to 0.25 times of K1. Yeah, I can say like this. Yeah, not this way, yeah, a small mistake in the calculation we committed. Yes, let me write it. Yeah, let me calculate. K2 is equal to K1 into 0.36, 4 times it will go. Yes, 0.36 4 times it will go. Okay, or 0.3 by 0.6, 1 by 2. 1 by 2 whole square is 1 by 4. Yeah, it is 1 by 4. Yes, it is I think yeah, 1 by 4. 0.3 is 0.2 times 1 by 2, it is 1 by 4. Yes, how much is 1 by 4? 0.25. Yeah, now the calculation is correct. See, one must solve correctly in the examination. See, this type of simple calculations will really kill our time. K2 is equal to K1 by 4. So K2 is equal to 0.25 times of K1. 0.25 times of K1. The option is there in the given options. Yes, it is there. Let's see which option it is. Option 4 it is. Option 4. So see, be careful while you are doing calculations, otherwise you commit mistake. Always choose a wise way to do the calculations. Don't go for lengthy calculations. Okay, yeah, this question, read this question. This question is from frequency response analysis. The phase angle at omega equal to infinity is asking the phase angle of this particular transfer function at omega equal to infinity. That is very easy. See, you want angle of g of j omega at omega equal to infinity. Yes, at omega equal to infinity, first of all, this j omega will give an angle of minus 90. So this angle will be plus 90 and this angle will be minus 90. Yes, and this angle also will be minus 90, as in that is there in the denominator. When it comes to upside, it will become minus 90. One pole in the first quadrant at omega equal to infinity will give always minus 90. 1 0 in the first quadrant at omega equal to infinity will always give plus 90. You can remember in this way also. If you cancel the things, then you are going to get minus 180. The answer is very easy. It is minus 180. See, I am telling you once again, the questions are not that tough as that of GATE examination. Sorry. Yes, let's go to the next question. Read the question carefully. The number of roots of the characteristic equation s power 4 plus 4s cube plus s square plus 8s plus 1 is equal to 0 lie on the right side of the s plane is. So previously also I told you, if this type of question is given, don't go for RH tabulation and all. RH tabulation generally anyone knows. It is a time taking process. First of all, it satisfied all necessary conditions or not? Yes. What is the general procedure? Take the given characteristic equation, formulate the RH tabulation, look at the sign changes in the first column of Routh array. If there are sign changes in the first column of Routh array, then the system is unstable, and number of right hand side poles is equal to number of sign changes in the first column of Routh array. That everyone knows. But my procedure is different. My procedure is different. Very simple procedure I am going to take up. First of all, let's check whether BC is greater than AD or not. What is the given characteristic equation? S power 4 plus 4s cube plus s square plus 8s plus 1 is equal to 0. First of all, for this system to be stable, for the system to be stable, yes, these two conditions must satisfy. One is BC must be greater than AD. Yes, one is BC must be greater than AD. Another one is D must be greater than B square E by BC minus AD. I told you what does it mean by A, B, C, D, E. Okay, compare this one with characteristic equation is equal to as power 4 plus bs cube plus cs square plus ds plus e equal to 0. Compare with that one. Okay, then see, find these two. Now very simply, just without pen paper we will solve this one. Without pen paper, BC is what? 4. Yeah, I can show you here. BC is 4, is greater than AD 8. Is it 4 greater than 8? No. The first condition is failed. If any one of those two conditions is failed, the system is unstable. If a fourth order system is unstable, the number of RHP are 2. If a fourth order system, this kind of fourth order system, what is this kind? After satisfying all necessary conditions, I'll give you a note point here. That's very important note point, okay? I'll give you a note point. Please, all of you note down this one. Note. If if a fourth order system is unstable after satisfying all necessary conditions. I'm not writing completely. After satisfying all necessary conditions, then the number of RHP is equal to 2. Number of RHP equal to 2. Okay, so option is 2, second option. Okay, so you can do the same thing with RH tabulation also, but see, for your explanation purpose I explained for this much time. Otherwise, just by looking at this one, BC is 4, AD is 8, first condition itself is failed, unstable. A fourth order system, after satisfying all necessary conditions, if it is unstable, the number of RHP will be 2. Answer is directly 2. 10 seconds, not more than 10 seconds. Okay, so like this in control systems, many shortcuts we are going to learn in the upcoming sessions. Okay, fine. Look at this question. This question also, just with the direct inspection we can answer it. What is saying? The system x dot of t is equal to a into x of t plus b into u of t with a equal to 1 0 1 1. It's a state transition matrix is. We all know that a state transition matrix phi of t is equal to e power at. But calculating this e power at is time taking. I won't say it is difficult, but it is time taking. Apart from that, there is a shortcut for us. See, we have some properties of this state transition matrix. What is that? Phi of 0 is equal to identity matrix. Phi derivative of phi of t at t is equal to 0 must give a. Check these two conditions. So which one satisfies these two conditions, that will be the answer. Means if I put t is equal to 0, then I must get identity matrix. If I derivative that phi of t, that is state transition matrix, this is STM, state transition matrix, and put t is equal to 0, I must get a. Observe it, all of you, observe it. Now look at the first option. If I put t is equal to 0, 1 0 0 1, yes, satisfied. 1 0 0 1, satisfied. First condition, I am checking the first condition. This is also 1 0 1 1, not satisfied. So forget about this option 3. This is 1 1 0 1, yes, this is failed. Forget about fourth option. Look at first two options. First two options are satisfying this first condition, then I have to go for the second condition. Suppose if only one option is satisfying the first condition, then that will be the answer. No need to go for the second test. What is the second test? Derivative it and put t is equal to 0. If I derivative it, what I am going to get? E power t will be e power t. If I put t is equal to 0 1. If I derivative this one, what I am going to get? T into e power t, t into e power t plus e power t. Okay, then how much I am going to get? If I put see, its derivative will be t into e power t plus e power t. If I put t is equal to 0, this will be 0, this is 1 1 1. No, this is not correct. Why? Because I must get 1 0 1 1. What's my matrix? A 1 0 1 1. Now look at this one. First condition is satisfied. Second condition, derivative it. This is e power t, this is 0, this is t into e power t plus e power t, e power t. Okay, now if I put t is equal to 0 in this one, I am going to get 1 0 1 1. This is what? 1 0 1 1. So option 2 is absolutely correct. No pen paper required for this one. If you are good at calculations, then derivatives, simple derivatives and all, you are going to solve it very easily. Your time will be saved. See, every exam will have some easy questions, some tough questions. Easy means if you know the concept, then only those are easy, otherwise those are tough. Okay, so that's why learn the concepts well, then you are going to solve the questions very easily. Then that time where we saved, see, we saved that time here, that time we are going to use for lengthy questions. Some questions obviously will be lengthy in any examination. Okay, let's go to the next question. The effect of phase decompensator on rise time and bandwidth is, we know one thing, that bandwidth into rise time is equal to 0.35. Okay, we all know that lead compensator, yes, increases the bandwidth. Lead compensator increases the bandwidth. If you observe carefully, if bandwidth increases, rise time will decrease. Why? Because that product must be equal to 0.35. Rise time is going to decrease. Okay, if time decreases means its speed is going to increase, in fact. Now, but here the question is related with the bandwidth and rise time. See, the effect of a phase lead compensator on rise time and bandwidth. First, rise time decreases and bandwidth increases. Option 4 it is option 4. Okay, let's go for the next question. That is very simple theory question. If you know the concept, you are going to tick for the answer, that's all. Yeah, this is also a very good question. The first two rows of a Routh tabulation of a third order system are as follows. So he given partial Routh array s cube s square 1 1, so and this is a 2 2, and this is s power 1 will be 0 0, we put here, this is going to be 0 0 0. One of the complete odd power row became 0. Then what we have to do, take its previous equation as auxiliary equation. What is the auxiliary equation? 2s square plus 2 equal to 0. Okay, now if I derive it, how much I'm going to get? 4s. Now we are going to fill this one with 4, and s power 0 I'm going to get how much it is? 4 into 2 minus 0 by 4, it is 2. Okay, Routh tabulation is completed. Are there any sign changes? Are there any sign changes? No sign changes. No sign changes. How many auxiliary roots? 2 auxiliary roots. Then the system will be marginally stable. Why? Because no sign changes and auxiliary roots are there, means auxiliary roots are also called as symmetric roots with respect to origin. How many symmetric roots we have? 2 symmetric roots. Why? Because the order of the auxiliary equation is 2. Okay, therefore 2 roots are there on imaginary axis, and yes, 1 root is there in the left half of its plane. Okay, system is marginally stable. How to find the location of auxiliary roots? Solve the auxiliary equation. What is the auxiliary equation? 2s square plus 2 equal to 0. From this you are going to get s is equal to plus or minus j1. Now observe, 2 roots at s is equal to plus or minus j, and 1 root in the left half of its plane. Option 3. Okay, this is very simple, just RH tabulation, or if you want the shortcut, that also I'll take up here. If you want the shortcut, that also I'll take up here. Yeah, what is the characteristic equation we are going to get? Yeah, from first 2 rows itself we can get the characteristic equation. What is that? S cube plus 2s square plus s plus 2. Yes, s cube plus 2s square plus s plus 2 is equal to 0. What is the condition for a third order system to be marginally stable? BC is equal to AD. Check. BC is 2, AD is 2. Okay. What is the oscillation frequency? Yes, sir. If BC is equal to AD, then a third order system is said to be marginally stable. What is the oscillation frequency shortcut? Omega oscillations is equal to under root of d by b or under root of c by a. Yeah, this should be compared with as cube plus bs square plus cs plus d equals to 0. Omega oscillations is equal to root d by b or c by a. How much it is? Yes, under root of d by b, a b c d, d by under root of d by b, it is 2, or under root of c by a, it is 1 by 1. How much it is? 1. Now location of pole is nothing but plus or minus j omega oscillations. We know, yes, s is equal to plus or minus j omega oscillations, that is equal to, that implies s is equal to plus or minus j 1. This is the location of poles on imaginary axis. We know that very simply. Yes, let's go for the next question, that is, which one of the following variables cannot be taken as state variable? Yes, we know that. See, state variable, yeah. What is a state variable? With which state variable is the one with which we are going to find the future of the system if we know the state variable present status and its previous condition. Okay, so current through an inductor, voltage across capacitor can be taken as state variable. Look at it. Current passing through inductor, yes, it can be taken as state variable. Voltage across capacitor, yes, it must be taken as state variable. Okay. Now current passing through a resistor, no, it is not a state variable. What I asked, which one is not? Option 3 is correct. Output of the integrator. Output of the integrator is also a state variable. Why? Because for an integrator we are going to take voltage across capacitor as the output. Voltage across capacitor is a state variable. Okay. Sorry. Let's go for the next question. Which of the following compensators is used to increase the speed of the response? Yeah, previously itself we saw that bandwidth into rise time is equal to constant. If I use lead compensator, bandwidth will increase, rise time will decrease, time is decreasing means speed will increase. Answer is lead compensator. Okay, yeah, let's go to the next question. Which of the following is not true? Yeah, first the option itself, state model of the system is unique. No. The state variable model of a system is a non-unique. Yes. What is the correct statement? State variable model of a system is what? Non-unique. Why? You know, if I have a circuit like this, see, I can solve this circuit in many ways. So if I give a system to you, you can go to model that state variable model in many ways. You can use KVL and KCL, or you can go with some theorems. See, there are many ways to solve a given network. As those many ways are there, those many different type of equations we are going to get, but finally solution will be the same. See, what is the contribution point of that? State model of a system is unique, but the state model solution of a given system is same. Suppose this is my system, this is my system, this is R, this is C, and this is Vi of t, and this is the current in this one is I of t, and if I take voltage here is Vc of t. Okay, see, I'll solve in one way, you'll solve in another way. Okay, that's not a problem. Means if I'm going with Laplace transform domain, okay, Laplace domain, I'm going to get one equation. You are going with KVL, or somebody who is going with KCL. So see, the modeling of the equations will be different, but finally if I ask you what is the voltage across capacitor, either you do in your way correctly, if I do in my way correctly, or somebody else do in their way correctly, then all the answers must match. Okay, so the first statement itself is not correct. He is asked which of the following is not true, therefore first option it is. Yes, then let's go for the next question. The initial slope of the Bode plot is an indication of, yeah, the type of the system. The type of the system. What is the type of the system? The number of poles which are present at the origin of an open loop transfer function. Okay, so suppose if I have one pole at origin, the initial slope will be minus 20 dB per decade. Suppose if I have two poles at the origin, yes, it is minus 40 dB per decade. In terms of octaves, minus 20 dB can be taken as minus 6 dB per octave. It is minus 12 dB per octave. Minus 12 dB per octave. Okay, suppose if I have 1 0 at the origin, then the slope is plus 20 dB per decade or plus 6 dB per octave. Plus 6 dB per octave. Same way, S square also either plus 40 dB per decade, plus 40 dB per decade, or plus 12 dB per decade, 12 dB per octave. Plus 12 dB per octave. So the number of poles which are there at the origin, or the number of zeros which are present at the origin, will decide, okay, the initial slope of the Bode plot. Initial slope of the Bode plot. So initial slope of Bode plot gives an indication of the type of the system. What is type? The number of poles which are present at the origin. The number of poles which are present at the origin. Let's go to the next question. Yes. A rough measure of bandwidth of a system is gain crossover frequency. This is a straight question. Okay, if more is the bandwidth, more will be the gain crossover frequency. Yes, sorry. Yeah, now this question, we'll solve this question. The open loop transfer function of a asymptotic approximation of the gain plot, in fact it is a Bode plot, shown below is, see, Bode plot is also called as asymptotic plot, approximate plot, okay, corner plot, in fact Bode magnitude plot, and that is having these many names. You don't feel like sir, here Bode is not mentioned, does the given plot is Bode plot or not? No, here he mentioned asymptotic approximation. Bode plot is called as asymptotic plot, approximate plot, okay, corner plot. Generally it is Bode plot. Okay, so these many names it is having. Now look at the Bode plot and get the transfer function. GSHS is equal to, yes, initial slope is some constant is there, k, initial slope is minus 20, therefore one pole is there at origin, type of the system, just previously we saw on question. And at omega equal to 2, this is 2 at omega equal to 2, slope is changed from minus 20 to 0. Slope is changed from minus 20 to 0 means it is going to have 1 0 at the origin, that is 1 plus s by 2. Okay, at 50 again the slope is changed from 0 to minus 20, 1 plus s by 50, 1 plus s by 50. Yes, now simplify this one, how much you are going to get. So this 50 will go upside, 50 by 2 is 25k into s plus 1 by s into s plus 50, or let it keep it as it is. You don't want the simplification, I think. Yeah, in the question he didn't simplify it, sorry. Yeah, in the question he didn't simplify it. Let me take a different eraser to erase this one. Okay, yeah, in the question he didn't simplify it. I'm not simplifying that one, I'm not simplifying it. Okay, observe it carefully, I want the value of k, okay. How to find the value of k? Let us see how to find the value of k. One hint regarding magnitude will be given to find the value of k. What is that? See, at omega equal to 2 the magnitude is 14. At omega equal to 2 the magnitude is 14. Yes, now let me do that here at omega equal to 2. So I know that at omega equal to 2 the magnitude in dB is 14. So 14 is equal to 20 log of, at omega equal to 2, does this factor will be there? No. Does this factor will be there? No. We have only k and s. We are going to get k by s is equal to j omega, omega equal to 2, k by 2. So when we get 14, 20 log of how much we are going to get? 14. So 20 log of 1 is 0, 20 log of 2 2 is 6 dB, 20 log of 3 is 9, 20 log of 9.5, in fact 20 log of 5 will be 14. So this k by 2 will be 5, k by 2 will be 5. So if k by 2 equal to 5, I can write here k by 2 equal to 5, I can say k equal to 10, put that here, k equal to 10, k equal to 10, and you simplify 10 into s plus 1 by 2 by s into s plus 50, or let's keep it as it is, not required, simplification not required, k is 10, answer is already there with us, 10 into 1 plus 0.5s, 10 into 1 plus 0.5s by s into 1 plus 0.02s, option 2 is the correct. Option 2 is the correct answer. So that's what I am saying, look at the options carefully, don't go for further simplification if not required. Okay, don't go for further simplification, that is going to kill your time in the examination. Please follow that instruction carefully, look at the options first before you do the complete calculation. Yeah, this question directly we can answer, no pen paper required for this one. So which of the following is the transfer function of the state space representation given below? Okay, he given x dot, actually this is x dot is equal to some a into x of t plus b into u of t, and y is equal to, so all that not required. If you look at the matrix of A matrix, what is that? -1 1 0 0 -1 0 0 0 -2. If you observe this one, this is in what form? This is in what form? In fact, diagonal canonical form, but it is not exactly diagonal canonical form, it is Jordan canonical form. First of all, two roots are repeating and only we have diagonal elements. This is diagonal canonical form. If one of the root repeats in the diagonal canonical form, that is called as Jordan canonical form. This is in Jordan canonical form, JCF. Which root repeated? -1 repeated, that's why we got 1 1 here. That's why you got 1 1 here. Suppose if -1 comes again here, then we are going to get 1 here, then we are going to get 1 here. Now if you see this -1 -1 and -2, what are the roots? Roots are -1 comma -1 comma -2. You look at which one is going to give -1 -1 and -2. Sorry, yeah, any mistake we taken? No, -1 -1 and -2. Which option is going to give? This is going to give +1 +1 +2. Okay, this is going to give +1 +2 +2. No, this is going to give -1 -1 -2. Option 3 is correct. Option 3 is correct. Just by looking at the answer options, we are able to answer it. Okay, that much easy it is. Let's go for the next question, ma. Let's go for the next question. Yeah, we are done with all the questions of HMWS. Yes, Hyderabad. Yes, Hyderabad Metro Water Service Board, TSPSC. Hyderabad Metro Water Board, TSPSC. We are done with all questions of control systems. In the upcoming sessions, yes, I'm going to complete 2017 paper AEE electrical. Okay, and a 2020 HMWS paper also I'm going to complete in the upcoming sessions. Thank you very much.